What if two black holes met and didn't miss? In the vast, silent theater of the cosmos, most celestial bodies are destined for near misses, their paths bending in a gravitational greeting before they continue on their separate ways. But for black holes, the universe's most extreme objects, the rules are different. In the dark, gravity finds gravity, an inexorable pull that once locked rarely lets go. This isn't a story of light and fury, but of invisible violence, a collision that shakes the very fabric of reality. It begins with two shadows, adrift in the void, their mutual attraction sealing their fate across millions of years. First, they dance. It's a slow, tightening waltz, a cosmic embrace that can last for eons. Each orbit is a step closer, a fraction of a second faster. With every rotation, they shed energy, not as heat or light, but as gravitational waves, ripples in space-time itself, slipping silently into the cosmos. Imagine the surface of a pond, disturbed not by a stone, but by the movement of the water itself. This is how they communicate their impending union, broadcasting their orbital decay across the universe. The space between them shrinks, the waltz accelerates into a frantic spiral, and the tidal forces become immense, stretching and distorting the very shape of their event horizons. If they are not alone, if they have dragged clouds of gas and dust with them, the spectacle becomes visible. The intense gravity superheats this captured material, forming brilliant accretion disks. Closer, faster, their disks flare, gas whips like fire around invisible mouths. This material, accelerated to near the speed of light, becomes a final, luminous scream before being consumed or flung away. It's a rare, violent light show that briefly illuminates the two titans just before they merge, a fleeting beacon in the darkness. Then, an impact that isn't an impact. There is no crash of matter, no explosion in the traditional sense. Instead, their event horizons, the points of no return, touch. It is a moment of pure geometry, a surrender of one reality to another. Two become one. A new, heavier, more massive black hole is born from the union, a single, larger shadow forged from the silence of its parents. The total surface area of this new horizon is greater than the sum of the two that formed it, a strange and fundamental law of black hole physics. In that final fraction of a second, the merger unleashes a cataclysm of pure energy. In a heartbeat, they release more energy in gravitational waves than all the stars in the observable universe combined. It is the most powerful event the cosmos can produce, yet it happens in near total darkness. Unless nearby gas is there to scream, this titanic release of energy is completely invisible to our eyes and telescopes. It is a storm of warped space-time, a gravitational tsunami that travels outward at the speed of light, carrying the news of the merger across galaxies. The newborn black hole is not immediately stable. It rings like a struck bell. This ring-down phase is the final sigh of the merger, as the distorted, lumpy horizon settles into a perfect sphere. Space-time itself hums with a distinct frequency, a chorus of quasi-normal modes that quickly fade into silence. It is this final, fading tone that carries the most precise information about the new object. On Earth, billions of years later, the faintest echo of this event might arrive. The laser arms of LIGO, Virgo, and Kagra, detectors of almost impossible sensitivity, catch the shiver. The wave, now stretched and weakened by its long journey, minutely compresses and expands the detectors. Scientists compare this faint signal to a vast library of theoretical templates, searching for a match. When they find one, they can decode the story written in the waves, the masses of the original black holes, their spins, their distance from us, and the precise properties of the new entity they created. We hear the ghost of a collision that happened when our own planet was still young. Up close, the laws of physics as we know them break down. Time warps to a standstill, and nothing, not even light, can escape the crushing gravity of the horizon. But out here, we are safe. The universe is vast, and the odds of such a wanderer drifting impossibly near our solar system are infinitesimally small. These events are not a threat, but a gift, a new way to observe the universe's most hidden workings. When the universe trembles, it's not a sign of danger. It's a message telling us that somewhere, far away, two dark giants just became one. The storm passes, the ripples fade, and the cosmos returns to its profound, patient quiet.